Okay, rule number 4, the independent point. The independent point, very important. Just give me your attention for that rule, very important rule. So in the previous rule, we can know that from the same extension we know the extrude for each of these contours. Now how about if we have something like this, okay? We have in the top we have two U's, U shape. U shape number 1, the biggest one, and we have U shape which is contour number 2. So this is contour number 1 and this is contour number 2. Now in this case, which one of these I have to give it a 20 millimeter extrude, and which of these two contours I have to give it a 30 millimeters? Can you think about that for some seconds? Which, the U number 1, should I give it an extrude of 20 or 30? And the same thing for number 2. Here in the previous one, it's obviously in the same extension we can know. From the same extension we can know. From the same extension we have known. But how about this? Which contour should I give it 30 extrude? Which one of these should I give it to 20 extrude? Okay, we have something we call it the independent point. So what should we do? Okay, what should we do in order to do that? Okay, I have to choose an independent point, okay, for the contour number 1. So we have how many points do we have? We have this 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 points. I have to choose an independent point. So can we consider this point as an independent point? No. Why? Because this point is intersected between contour number 2 and contour number 1. So it's common point. I have to choose an independent point. It's not common, it's not intersected between two contours. So I can, for example, give this point, yeah, this is an independent. It's not related, this point is not related to contour number 2. Okay, it's only related to contour number 1. So I have to choose this point, okay, and I have to go, okay, I have chosen this point. Now, how can I know the extrude of this contour? If you go for the opposite side, which is the front, you will find maybe a dash lines or solid lines. In the front of this point, in the next view, in the opposite view, we can find a dash line or solid line. Now, the length of this dash line or the solid line is the extrude of this contour. Now, what is the extrude of contour number 1? Obviously, we have a dash line. This length of this dash line is 30. Okay, so I'll give it this extrude 30 millimeters. Very simple. So I have to draw the top, then I'll give the U shape number 1. Okay, I'll give it an extrude of 30. Now the same thing for contour number 2. Is this an independent point? Yes. This point is not related to contour number 1, or not intersected with contour number 1. So this is an independent point. Now I have to go to the opposite view. I will see even a dash line, either a dash line or a solid line. So I have in this case a solid line. So what is the length of this solid line? 20. So after we draw the contour number 2, the bigger U, I'll give it an extrude of 20. Very simple. Okay. Now I have a question to you, and think about it. Suppose that I want to make an extrude of contour number 2. Is this an independent point? you would say yes, this is an independent point. But I will say no, this is not independent. Why? Because this point is this point is this point. So this point is intersected and common between contour 1 and 2, and this point is also common between contour 1 and 2. So although this point can be considered as independent, but you have to see what is in the point in the same line. Okay, what are the points on the same line? So this point is also this point and this point. So we cannot choose this as an independent point. But you can use this, for example, yes, because this is an independent and also this is independent. So be careful when you choose the independent points. It has to be, okay, to consider that in your mind. Okay, so this is what we call the independent point. We have to choose an independent point, then choose one of these points and go up. You will find either a solid line or dashed line. The length of this dashed line or solid line is the extrude of this contour. Okay. Also, you can see that for the you can apply the rule number 3 also, the same extension. So this is the U, the width of this U, and you will find the same width in the opposite side, which is this area from down to up, and you can see this is the height of this area, which is 30. So the U number 1 has an extrude of 30. You can also apply rule number 3, but you can choose one of them, the easiest way for you can that you think that it's easy to you. For example, also contour number 2, you have to see the width of this U, okay, and you have to see what is the same width in the opposite side, and you have to know what is the height of this area. What is the height of this area? Okay, which is 20. Okay, so you can choose one of them, but I always prefer the independent point. It's easier to see what is the extrude if I have a drawing that has intersected contours. Okay, so I prefer to use this idea, the independent point. Let's go to rule number 5. Let's go to the rule number 5. Rule number 5 is very easy. Solid and hollow cylinder. Solid and hollow cylinder. If you see in this, in the right, for example, if you see a rectangle, and inside this rectangle we have a center line, okay, definitely you can say that this is a cylinder. Sorry, this would be a cylinder. If you have a rectangle and inside this rectangle you see a center line, you can know that this is a cylinder. This is a cylinder. Okay. Now, even if I don't give you the front, you can say that this is a cylinder, because we have a center line inside. Okay. Now, how about if I give you a rectangle that has cylinder and you have two parallel dash lines? Two parallel dash lines. You can say that this is a hollow cylinder. This is a hollow cylinder, which means that there is an empty area inside here, and this area is cylindrical. Okay, so this is rule number 5. If you saw a rectangle, if you see a rectangle, inside this rectangle we have a center line, that means that this is a cylinder, even if I don't see the front. If we see a cylinder, a rectangle have two parallel dash lines, and there is a center line, that means this is a cylindrical hollow cylinder. Okay. Now, how about this? I'll give you some time to see what is this. Okay, this is also a cylinder, but this cylinder has different hole inside it. For example, you can see this is a parallel dash line, then this is a parallel dash line, then again this is parallel dash lines. So which means that this cylinder has a hole, okay, but not straight hole, not straight. That means that this for this area we have a diameter, say for example this is 40 millimeters, for example 20 millimeter, then it becomes bigger, the hole becomes bigger, let's say it's 60 diameter for like 80 millimeter long, then it becomes a small hole, say it's 30 millimeter diameter for 20 millimeter long, and it comes from the next area. So when you see this rectangle and it has different parallel dash lines, that means the hole inside is not does not have the same diameter. It becomes bigger, the hole becomes bigger, then big side, then bigger, then smaller, and so on. We need that in the pipes. Sometimes we have a flow dynamic, we have water inside, then I want to store this water, then we want to make a pressure so the water becomes flow strongly from the other side. So we need sometimes to make different holes. So this is the idea of that, this shape, okay? Because sometimes you have to know what, if it is just a straight hole or different holes inside the cylinder. Okay, in the next video we'll talk about rule number 6. Thank you very much.